There we are. Linear relations, workplace 30. Right off the bat, it's a real quick review, in case you've forgotten stuff, which very well could have happened. Slope refers to the steepness of a line. Okay. Other words are sometimes used to refer to slope. We're talking about a roof, you'd say pitch. On a road, you'd be calling it the grade of the road. Slope is the ratio of the change in the vertical distance over the horizontal distance. That's, change in y over the, I didn't mean to do that. The change in y over the change in x. That's one way. Well, the other way we use often is the words rise over run. Rise meaning the up, down, possibly down, we'd use a negative rise. Over the run, from left to right, how far you go over. Now, keeping rise and run over in mind, let's go through these first two examples real quickly. Calculate the slope of the line that has a rise of 15 and a run of 6. So, we're going to use the letter M to mean slope. The rise over the run, I'm going to write it down this one time here. Rise over run, just to remind us. So the slope in this case is, it directly says rise and run, 15 over 6. And the units match, so it's fine. Now, you can reduce that fraction. If you start with numbers, don't do a decimal, just reduce fractions. I'll give you a second here. What number divides out of top and bottom then? Do you reduce? Well, I have to separate Gerald and you if it continues to be a problem. I don't think it will. Okay. Anyways, what can we yank out of both? 15 and 6. Common. What's the common factor? The biggest? 3. Yeah, so 5 out of 2. So this reduces to 5 out of 2. If you divide both by 3, I'll put that in there after the fact. That's what you're thinking now. Oh, 5 out of 2. We just leave it like that as a fraction. If you want it as a decimal, you just put 5 divided by 2 in your calculator. You get 2.5. There's no need to. And how about the next one? If the same line is extended to a run of 9 meters, what is its total rise? So what we're saying is this is the same line. Slope is rise over run. So I'm going to write it down just because I'm the words. Rise over run. Now think of this. Come on in, have a seat, and I'll get your stuff after I set up with these guys. What is the value of M? We have it from the previous problem. I'm going to make sure Tiana and Jasmine, everyone's watching too. I know you're busy writing something down. From here, we're using the same line, so it's the same slope. The slope in this case is 5/2. So I'm going to replace the letter M with 5/2, if you see what I mean. So instead of on the left having M, I'm going to put this as 5/2. Now, is there any confusion what I just did? You could have used 2.5 as well. Now, you see how this is working here? The same line, so that's why I use the same slope of 5/2, is extended to a run of 9 meters. So the run in this case is 9 meters. So the run goes on the bottom. Do you want to go to Ms. Rogers' room and get my calculators set? Thank you so much. So 9 meters, I don't need the M in there. I want to find the rise. I'll call that X. We know how to solve this equation, right? You know how to solve this equation too, right? I'm going to grab you your stuff and all this. and come up with an answer for me, and then I'll start on the 20 stuff after. Justine is what comes today? Yeah? Okay. I'll get a third one now. Okay. We know where we're at. Does this make sense to you, what I was doing? Good? Say what? You got an answer for yours? Awesome. Great. 45 cut in half is 22.5. Great. So the total rise in 30 level, I'm going to get more on you as far as word problems. So I'm going to say the rise is 22.5 meters. So it's going to start to be an expectation that we label our answers with a small statement at the end. Hey dear, welcome to Workplace Leader. Where you go? Always a treat. Now, I'm flipping to page 2 right away though. And working with linear relations. I want to go through this list with you, okay? Did that photocopy well for it? Yeah, it's not too shaded or anything. Okay, a graph on a coordinate plane shows a relationship between the independent variable and dependent variable. Huh? Well, one depends on the other is what it really means. Dependent. Either. I'm recording the lesson as I do this, so I'll talk to you in a minute or, well, I'll do about 4 minutes. The linear relation is a relationship that forms a straight line when the points are plotted on a graph. The slope of the straight line is constant. If the line passes through the origin, 0, 0, it's called direct, a direct linear relation. Now, this is what we're going to look at right now, working with a direct, with the linear relation here. Okay, let's just take a look at this chart. Hours worked and total earnings. You know how we usually use X's and Y's? You don't have to. You could use H and E for earnings or T for total or something like that. But anyways, this is like an XY list. So the kids make it $12.50 an hour. Not bad for babysitting. If you work 0 hours, makes sense you make $0. If you work 1 hour, makes sense you make $12.50. 2 hours, you just double that, right? 5 hours, 5 times $12.50, it'd give you $62.50. Now, all I'm wondering here is, which one's independent, which one is the dependent variable? Now, you don't usually use that words, but think of it this way. Does the amount of money you make depend on the hours you worked, or is it the other way around? The hours you work depends on the amount of money. I'd say, I think you guys are nodding your head, which one? The money depends on how many hours you work, right? So that's why we would say the earnings, or the money, is the dependent variable, okay? The dependent variable is the earnings, whereas the independent is the hours worked. Now, you usually got to just think about it for a minute and think, which depends on what? How much I make depends on how many hours I work. Use the data to draw a graph, and we'll connect the points. We'll about that in a second. Should you connect the points? We will. Why or why not? Because we'll do that later. So, Kalinda's earnings from babysitting. Next page, just so that I have that graph for you on the next page. Just it wouldn't fit nicely on that handout. Let's go through here. Obviously, we'd start at 0. Well, not obviously, it's the time. Then 1 hour of work. Let's put the hours. The independent always go on here. Okay? Hours worked. Okay? 0, 1, 2, 3, 4, 5, go to 6, 7. 7 hours. Okay. Now what variable do we probably want to hide there? And are you a math 30 or 20 student? 20? I'll be with you guys just after I get these 30s through, okay? What would make sense, an H or a W? What do you guys want to use for the variable instead of X? Normally you put X down here, but just tell me which letter for hours worked, what do you want to use? H? Okay, that makes sense. We'll use this as abbreviated, and our equation is H. Now on the side, your earnings. And that's in dollars. But let's use the letter, oh, this is getting confusing, the letter E for earnings. Because we won't put a dollar sign in there. Okay. You don't get higher than $100, so let's go 20, 40, 60, 80, 100. And Brooke, have a seat somewhere and I'll get you on. We'll just finish this up. I got 2 or 3 things on the go here. Now, do you guys know how to do this graph? Then once I have this, you go with 0 and 0 because that's the first thing. At 1 hour, you go to 1250. So I'm going to just remember those two. And I say, well, at 0 hours worked, I earned $0. At 1 hour, I earned $12.50. Well, $12.50 doesn't appear on here, but I know it's more than halfway up because 20 is the full line, right? So I'd make a dot at where I think $12.50 would appear. Then I'm going to go back to the chart and I'd see that 2 hours is $25. Well, 2 hours, $25. And what 2 hours, $20 is right there. I got to go a little higher, but not halfway would be 30. So I'm going to put my $25 right about there. When you do all that, use a ruler to connect the dots. And I'm going to just flip back for a second. And see if you can come up with the slope of the line. I'm going to just rewrite. And if I can get your attention, I know you know how to do this, but I got to just stop and move on for a second here. So, Tiana, Faith, and stuff, maybe just as a reminder for this D thing, do you remember slope being you take the difference, rise over run, right? Go y2 minus y1, x2 minus x1. Now, it's been 6 months since you've seen that pretty much. But that slope formula means take the difference between 2 points in the y-axis and then in the x-axis in the same order. That rings a bell, taking the slope. Or else you can just count the rise over the run. And that should help you do those. Once you've done those two, I would ask you to skip up to your assignment here and do the first page for sure. And you could probably get into the second, the second page as well. Anyways, this should get you going on that. There's some more stuff for me to show you, but I need to also help my Math 20 students too, okay? So I'm going to stop the recording here. And you guys got some stuff to work on.